Okay, today we're talking about 3.5 Algebra 2, graphing square and cube root functions. I set up a square root of x and I set up a cube root of x. You can always do them by simply making an x, y table. The square root of negatives you cannot use. The square root of 0 is 1. I'm sorry, square root of 0 is not 1. Square root of 0 is 0. Square root of 1 is 1. If you put in a 2, you get the square root of 2. If you put in a 3, you get square root of 3. But what happens if you put in a 4? Square root of 4 is a 2. So if you don't mind, I'll stick with just the integers. If I put in a 4, I get out a 2. So I'm going to graph these. 0, 0, 1, 1, and 4, 2. 4, 2. What if you put in a 9? What's the square root of 9? So if you went all the way out to 9, it would be a square root of 9 is 3. And so here is the square root of x. Very important graph because from here on we'll shift it, reflect it over the x-axis if you put a negative in front of it, things like that. Same thing with the third root. You can take third roots of negatives. The third root of negative 8 and the third root of third root of positive 8 is 2. The third root of negative 8 is negative 2. Why? 2 times 2 is 4 times 2 again is 8. If you put in a negative 1, the third root of negative 1 is negative 1. Third root of 1 is 1. Third root of 0 is 0. So we'll plot these points. Negative 8, negative 2. Negative 1, negative 1, 0, 0, 1, 1, and then 8, 2. So it happens to curve like this. That's called concave up. Then it changes to this, which is called concave down. I'm not going to ask you about concavity, but that's a graph of the third root of x. So hopefully we know what the square root of x looks like and the third root of x looks like. Okay, this is example 4 in section 3.5, I believe, and we're going to talk about different approaches. I see this as a square root, and I know what square roots look like. They look like this. However, it has a negative, so that means it's going to be flipped over, so it's going to be more like this. This right here means it's shifting 3 to the right, so 3 to the right. And this means 2 up, so it'd be 2 up. My guess is the final graph's going to look something like this, just as a general shape. I don't know. Let's figure it out and find out what we get. You can always get it by graphing by an XY table. I recommend that you make what's underneath the radical called the radicand. If you make the radicand equal 0, what would x equal? 3. And that's what I always put in the middle of my XY table. So if I use a 3, what do I get if I put a 3 in? Well, let's find out. I believe this becomes 0 plus 2, which makes it 3, 2. So it's going to be up here at 3, 2. Kind of just like I projected down here. Now let's choose a value like a 2. What happens if you put in a 2? Oops, sorry. What happens if you put in a 2? Well, what's 2 minus 3? Negative 1. Can you take the square root of a negative? No, so you really can't use a 2. However, I think I could use a 4. So if I was to put in a 4, what would that give me? Negative 2 times the square root of 1. Well, what's the square root of 1? I think this would give me, if I put in a 4, right? If I put in a 4, I got out a 0. So 4, 0. And I know what it's going to do. I could keep plotting points, but I do think it's going to do this. I don't think I'd put in a 5 because that would give me a square root of a 2. But what might be a good thing to plug in there? How about if I put in a 7? What would happen if you put in a 7? Would that give me a perfect square root? So negative 4 plus 2. If you put in a 7, you'd have a negative 2. 4, 5, 6, 7, down here at negative 2. And hopefully this is what this helps through graphing this is a square root with a negative and it's been shifted. Okay, we're going to do 3.5, numbers 11 to 23 odds. Here's number 11. I'm probably just going to make an XY table, and I'll put in some very convenient values that have third roots, such as negative 8, negative 1, 0, 1, and 8. The third root of 8 is 2, so the third root of negative 8 is negative 2. So I'm going to go through, so if I put in a 8, if I put in an 8, I get 2 times the third root of 8, which is 2 times 2. So really this y value is 4. And this would be a negative 4. Now how about if you put in a negative 1? The third root of a negative 1 is negative 1. So 2 times negative 1 is negative 2. If you put in a 1, you get 2. 0 gives you a 0. So it's going to go through 0, 0, 1, 2, 8, 4, negative 1, negative 2, and negative 8, negative 4. So it's going to look like all third roots do, but it's a little elongated, a little bit larger. And here's the sketch for number 11. We're supposed to graph it, label, state the domain and range. Domain is all reals, because you can take a square root of negatives. All reals sometimes is indicated negative infinity to infinity. How about the range? Does this continue upward and downwards? I think it does down and it does continue up. So again, all reals, or negative infinity to infinity. So there's domain and range. Okay, to do one like 17, you'd have to realize that the 1/2 power means a square root. If you ever want to do a domain on a square root, you take the radicand, the part under the radical, make it greater than or equal to 0. So your domain is x has to be greater than or equal to negative 1. So I'm not going to go very far to the left. You may notice that I emphasize the top part of this graph. That's because I have to add 8. So that means everything's moving up. So let me increment this a little tighter. 1, 2, 3, 4, 5, 6, 7, 8. Now I got to go a little higher. There's 10. And so on. So if I make an XY axis, and or XY table, and let's suppose I put in a negative 1. What is negative 1 plus 1? Would it be 0? And what's the square root of 0? Plus 8 is 8. So I believe this is going to start at negative 1, 8. What would happen if you put in a 2? Well, 2 plus 1 would be a 3. That would be a square root of a 3. I don't really know a square root of a 3 that well, so I might not use 2. However, how about if I use a 0? Would 0 work? What's 0 plus 1? 1. Square root of 1 is 1. 1 plus 8 is 9. So I believe it's going to go through 0, 9. And let's put in something like a 3. Why a 3? Because when you put in a 3, 3 plus 1 is 4, and 4 has a nice square root. So 2 plus 8 makes it 310. 310. And it's going to look like all square roots, which is pretty much half of a parabola. So what is your domain? X has to be greater than -1. What is the range? What are these y's bigger than? 8. Y is bigger than or equal to 8. Sometimes written in including 8 to infinity. You can never include infinity. So there's domain and range. Okay, for 21, I'm going to put in numbers for x. What makes this 0 is -7. So I'll probably put in a -7 first. If I put in a -7 plus 7 means you have the third root of 0. And the third root of 0 is 0. And 0 times -3 is 0 minus 6. I think I'm going to go through -7, -6. So I believe it's going to go -7, -6. I can take third roots of negatives, so I can go further negative. I can plug in a -8. If you put in a -8, you get the third root of -1. The third root of -1 is -1. So that makes 3 minus 6, or -3. So -8, -3. 1, 2, 3. -8 is about here. So -8, -3. I know what cube roots look like, but this has a negative, so this is probably going to flip it and look more like this. Since it's shifted over, I know it's going to come like this and then start going the other way. So I know it's going to do this and then probably go out this way. A little exaggerated there, but let me rewrite this: -7, -6. Try and connect these a little smoother. Now, what do we have here? What if I put in something like a -6? Can I use a -6? If you put in a -6, what do you get? Well, let's put in a -6 plus 7 is a 1. What's the third root of 1? 1. 1 times -3 is -3, and -3 minus 6 is -9. So 6, -6, -9. Anyway, it's going to look like this. I could put in more numbers. What is your domain? For third roots, the domain and range will be all reals. So the domain and range is all reals. Why? Because you can take third roots of negatives. And the y's are because this, whether or not you see it, this continues up and this continues down. But it should look something like this.